Good morning students, I am Chithra from EC department. I am going to take a topic on computer networks. Okay? Computer networks. So computer networks is a branch of science that deals with interconnection of different number of computers or nodes or other devices using a set of serial links or parallel links. Okay, so computer networks is a base of different generations of now what are the different generations of networks is coming. So the base of that networks is that computer networks. So here for building a network there are a number of requirements and criteria we have to check in. So what are the factors or criteria that is responsible for building a network or connecting two devices using a link? This link may be wired or wireless. Okay, either wired or wireless. We have to note down what are the requirements for connecting two devices. So what are the requirements for connecting devices are? So first requirement is the stakeholders. So stakeholders are those who helping those customers or servers. So the users who are using the network, they are termed as customers, and the stakeholders, you are having three types of stakeholder requirements. That is, first one, you are having application programmer. Second one is a network operator. Then third one is network designer. So network application programmer, application programmer is a thing that is they what do is they will generate some application programs that can connect two devices. So the main function of application programmer is to write programs that can connect two devices using a set of serial links or parallel links. Then second one is network operator. The network operator, it lists the characteristics of a network, that is they manage and administer the network based on the user's application. So there are number of network operators now available across India, that is Airtel, Jio and all. We all know that. Second point is scalable connectivity. So scalable connectivity is what do you mean by scalable? Scalable means you can extend or just reduce the network. So in order to do that, we are having two types of configurations. That is, first one, point to point and multi-point configuration. So point to point configuration, you are having two devices that are connected through a single link. So only a single link is available. For multi points, you are having number of links connected to number of devices. Okay, so this is multi point. So here you can access, and also you are having a single link that is accessed by different number of users accessing same link. That is also you are having a multi-point configuration. So these two using these two configuration, you can scale the connectivity of the network. And also if there are different categories of network such as LAN, MAN, WAN. So these are the basic categories of network. What are LAN means local area network, MAN metropolitan area network, WAN wide area network. So what is meant by a LAN? LAN means what? It is connecting the devices which is inside the building or inside an office. Okay. So here you are having number of topologies. So in to build a network, you need, what are the things you need is, you need to know the line configuration. Line configuration means what is a line, that is point to point or multi-point configuration, and then you have to identify what is the network topology you are using. Network topology, there are number of different categories. That is first one, there are categories of topologies of network is star, mesh, then bus, ring and tree topologies. These are the topologies of network. Using these topologies of network, they have to, the physical characteristics of a network is designed by these network designers. And also here for LAN, mainly LAN is for that is inside the building, and MAN, metropolitan area network, this is connecting different cities and also different areas. Okay, so the basic network is local area networks, that is inside a building. Then above that you are having MAN, metropolitan area network, and the global network, that is connecting all the throughout the world, that is WAN, wide area network. So this is a representation for categories of network. So these all criteria is coming under the scalable connectivity. So so in order to scale the connect, that means you have to add the number of devices more, or you have to link, you have to extend the coverage. In order to extend the coverage and all, you have to know these criteria. And what are these topologies of network? So first topology is star topology. Here in star topology you are having a central hub that is connected to number of devices. Okay, so this is a star topology network. And next one is mesh network. Mesh network, so in mesh network, each and every devices are connected to each other. There is no that is not neighboring devices. All the devices are connected to each other. So here the signal is circulating throughout all the devices. So here the major disadvantage is more number of cabling is required. Then bus topology. Bus topology means you are using a central cable, and from that you are tapping the signals. Signals to each devices. So this is bus topology. And next one is ring topology. Ring topology, so in ring topology, the devices are connected circularly. So the signal is circulating throughout the devices. Here the difference between this mesh topology and ring topology is, here the neighboring devices are only connected, and here this all devices are connected. Then here tree topology. Next one, tree topology is, tree topology is a variation of star topology. The star topology is having a central hub, and that is connected to number of devices. In tree topology, these hubs are connected to different hubs. So more number of hubs. So more number of hubs are used, and each hub is connecting one set of devices. So each hub is controlling some set of devices. So this is a tree topology. So next one is these are the requirements under scalable connectivity. So next one is you are having cost effective resource sharing. Third point. Cost effective resource sharing. Resource here means what? Here the bandwidth available for the transmission of data. So how we can transmit the data from different number of users. There are more number of users, So you have to transmit the signals, all the signals through a single channel. How we can do this? So you have to, one type of transmission technique is multiplexing. So you can multiplex these signals into using some multiplexing technique, and you can transmit the signal and then you can demultiplex here and then transmit to the receiver. Multiplexing technique. Okay, here in the sender side multiplexing is done, in the receiver side demultiplexing is done. So what is meant by multiplexing? It is grouping of signals from different users. So there are different types of multiplexing techniques are there. That is time division multiplexing. Second one, frequency division multiplexing. Third one, you are having statistical multiplexing. The different types of multiplexing techniques are there. So time division multiplexing, you are allocating, that is, they are sharing the time into different users. So for each user, the time is shared. Okay, so if a channel is having a frequency or a bandwidth of 20 kilohertz, this 20 kilohertz bandwidth is shared by some 5 number of users. So these 5 number of users, how they are shared is, so this first user 1, user 2, user 3, user 4 and user 5. These 5 number of users are sharing, that is at time t1 this user 1 will be transmitting the data, at time t2 the user 2 will be transmitting. So the time is shared. In time division multiplexing, time is shared between among the users. So frequency division multiplexing, this frequency, that is 20 kilohertz, this frequency is shared. That is, in frequency there is time is same, that means simultaneously the users are transmitting the data using some different frequencies. This 20 kilohertz is divided among the users, that is F1, F2, F3, F4. Here you are dividing the time T1, T2, T3, etc. Here it is dividing F1, F2, F3, F4, etc. Okay. Then statistical multiplexing, here also this TDM and FDM, like time and space. Here space is divided, that is time is also shared and frequency is also shared, and more number of users are allocated. Okay. Then you are having that is connection oriented and connectionless protocols. So these are the requirements for building a network. So first requirement is stakeholder, second one is scalable connectivity, third one is cost effective resource sharing. So in network there are other types of protocols. Okay. So there are in computer networks you are having protocol configuration. First one, network configuration, then you are having protocol configuration. That is, protocols means a set of rules that governing a function or a work. So if you have to transmit a data from sender to receiver, it have to follow a set of rules. So that is the protocol. Okay, so they are I have taken the topologies of network. For each topology, each protocol is there. For every topology there. So for ring topology, one token pass ring, likewise different protocols are there. Okay, for building a network, you are because of its complexity, because the network is very complex. That is, if you are using a wide area network, if you are thinking about wide area network, the network is very complex. That is, it is connecting throughout the world. So in order to reduce the complexity and we have to manage the network, we are network designers have introduced an OSI layer model. OSI layer model. What is meant by this OSI layer model means open system interconnect model. Open system interconnect model means you can connect any device to any device. That is open system. That is this OSI layer model having 7 layers. 7 layers like physical, data link, network, transport, session, presentation and application. Physical and data link, network, transport, session, presentation, application. These 7 layers forming a open system interconnect model, which is helping the devices to connect each other. Okay, so physical layer, this physical layer, what it does is it will give the connection between physical connection between two devices. That is what is the type of transmission mode, what is the type of cable you are using, then what is the type of signal you are using. So that all functions are done by physical layer. Then what is this data link layer does is, this data link layer, it will control the data flow and also control the error. Okay, so this is the center side. For an OSI model, you are having sender and a receiver side. So this is the sender part and this is the receiver part. So here the data is flowing from sender part, from application layer to physical layer, and in the receiver part, this is the receiver, this is the transmitter, and the receiver part, this data is flowing from physical layer to application layer.